Well, I don't think we're going to necessarily ask for a declaration of war. I think we're just going to kill people that are bringing drugs into our country.
At 2:17 a.m. on Interstate 10 in Arizona, a routine traffic stop quietly crossed a line that American law enforcement rarely sees. A highway patrol officer clocked a semi-truck at 83 miles per hour in a 75-mile zone, a minor violation that normally ends with a warning or a citation. When the officer approached the cab, the situation changed instantly. The driver's seat was empty, the dashboard was lit, and the truck was still running. Yet there were no markings to suggest it was a legal test vehicle or part of any approved autonomous program. In that moment, this was no longer a traffic issue, but an unexplained system operating on a public highway without human control. A records check made the situation more serious. The license plate belonged to a truck, reported stolen from a California logistics company weeks earlier, and the trailer remained sealed, indicating it was actively carrying cargo. When the vehicle accelerated back onto the highway on its own, the stop escalated beyond local authority, triggering notifications across federal channels. What began as an ordinary enforcement action now raised a far more dangerous question. Because if a heavy commercial vehicle could move freely across state lines without a driver, then the problem was no longer speed or theft, but control. And as federal agencies moved in, it became clear that this single moment on an Arizona highway was only the visible edge of something much larger. If you want clear, fact-based analysis on how moments like this turn into national security operations across the United States, subscribe to Military Power so you do not miss what happened next. What began as a single traffic anomaly quickly expanded into a national-level investigation once federal agencies connected the data. Analysts reviewed traffic cameras, toll records, and commercial vehicle databases, and these sources confirmed that the driverless truck detected in Arizona was not alone. Further analysis showed that 23 autonomous trucks were moving at the same time, each operating on pre-planned routes that mirrored legitimate freight activity and avoided patterns that usually attract enforcement attention. The geographic reach of the convoy made the situation more serious. Investigators determined that the trucks were active across at least 12 states, crossing multiple jurisdictions without stops, inspections, or human intervention. Because the vehicles relied on automated systems rather than drivers, they did not require rest, food, or communication during transit, allowing continuous movement that blended smoothly into overnight highway traffic. Weight data and trailer specifications provided a clearer picture of the cargo. Each semi-trailer was assessed to be carrying more than 2 tons of fentanyl, based on axle load measurements and standard shipping configurations. When combined, the total volume approached 50 tons, a quantity far beyond a single market supply and large enough to strain public health systems across several regions. Route mapping revealed that the operation focused on population and distribution rather than speed alone. The trucks were directed toward major metropolitan areas such as Los Angeles, Chicago, New York, Miami, and Seattle, cities that offer dense demand, established criminal distribution networks, and access to secondary transport corridors. By moving toward multiple urban centers at once, the operation reduced dependence on any single route and increased resilience against partial interdiction. One defining feature of the convoy was the complete absence of human drivers. In traditional trafficking operations, drivers represent both a necessity and a vulnerability, as they can be stopped, questioned, or pressured into cooperation. In this case, automation removed that layer entirely, leaving no individuals to detain during transit and no immediate human errors to exploit. This design choice had important analytical implications. Automated systems do not experience fear, fatigue, or uncertainty, and they do not deviate from instructions due to emotion or stress. As a result, enforcement agencies could not rely on behavioral indicators that often expose illegal transport, such as erratic driving or inconsistent communication, making detection more dependent on data analysis than roadside observation. From a broader perspective, the convoy illustrated a deliberate shift in criminal logistics. By replacing human labor with autonomous technology, the cartel reduced exposure to routine traffic stops and increased consistency across long distances. This model challenged existing enforcement frameworks that were built around human decision-making and signaled a transition towards system-based trafficking operations. As authorities pieced together the scale of the movement, it became clear that this was not simply a large shipment, but a proof of concept. The coordinated use of 23 vehicles across 12 states demonstrated how automation could multiply reach while reducing risk for operators. Understanding this scale was essential because it defined the threat not as isolated criminal behavior, but as an evolving logistical strategy. This realization set the foundation for every decision that followed. Once the magnitude was established, the investigation shifted from confirming numbers to assessing systemic risk. The challenge was no longer how to stop one truck, but how to confront a model capable of repeating itself across the national highway network. That understanding framed the operation as a national security concern, rather than a routine enforcement case, shaping the strategic response that followed. It also explained why traditional assumptions would no longer apply under emerging automated conditions nationwide scale. As the scale of the autonomous convoy became clear, U.S. authorities shifted their focus away from highways and toward the systems quietly directing the movement. Investigators from the FBI and DEA worked alongside cybersecurity specialists to analyze the encrypted signals that coordinated the trucks across state lines. These signals did more than provide navigation, as they adjusted speed, timing, and routing based on traffic conditions, showing that the vehicles were part of a centralized control structure rather than independent units. Technical analysis revealed that the communication network relied on multiple layers of encryption and routing complexity. Commands were passed through several foreign networks before reaching the trucks, a design intended to slow attribution and hide the origin of control. This structure reduced the risk of a single point of failure and complicated real-time tracing. For investigators, it was an early indication that the operation had been built with long-term resilience in mind, not as a one-time shipment. Despite these digital barriers, the decisive breakthrough came from a physical detail. One of the trucks reported stolen months earlier transmitted a final GPS signal before dropping out of commercial tracking systems. When this location was compared with shipping records and vehicle modification data, it pointed to an industrial zone in northern Mexico. Unlike abstract signal paths, this location offered a concrete lead that could be verified on the ground. Mexican federal police were notified and coordinated closely with U.S. agencies to act on the information. When the site was secured, authorities did not find a typical storage depot. Instead, they uncovered a technical facility dedicated to vehicle conversion and system management. Inside were servers actively directing truck movements, several vehicles undergoing modification for autonomous use, and a team of engineers responsible for maintaining and updating the software. This confirmed that the convoy was supported by a permanent operational base with specialized technical capacity. At this point, investigators faced a strategic choice with significant consequences. Shutting down the servers immediately would have disrupted the convoy, but it also carried risks. Sudden loss of control could have caused trucks to stop unpredictably on public roads, potentially leading to traffic accidents or hazardous exposure. Because the trailers were known to contain large quantities of fentanyl, any uncontrolled event was considered unacceptable. Instead, federal planners chose a more deliberate approach. Cyber teams began accessing the system gradually, avoiding actions that might alert operators or trigger defensive responses. Monitoring tools were introduced to observe how commands were issued and how vehicles responded to changes in traffic or route conditions. This process revealed the internal logic of the system, including safety thresholds, route prioritization, and communication hierarchies. By infiltrating the control network rather than destroying it, authorities gained two critical advantages. First, they were able to influence vehicle behavior without causing abrupt disruptions. Second, they collected detailed intelligence that could be used for prosecutions and future prevention. The cartel's own infrastructure became a source of evidence documenting how automation was being used to move illicit cargo at scale. This intelligence breakthrough reshaped the operation. Control of information allowed law enforcement to plan subsequent actions with precision, reducing risk to the public and to officers. It also demonstrated that confronting automated criminal systems requires patience as much as technical skill. Understanding how software, logistics, and human expertise intersect proved more effective than immediate force. The discovery of the control center marked a turning point. It showed that behind the driverless trucks was a coordinated network combining technology and organization. This realization set the stage for the next phase, where access to the system would be used to neutralize vehicles safely and systematically, rather than reacting to them one by one. Once federal authorities secured operational access to 19 of the 23 autonomous trucks, the focus shifted from intelligence collection to controlled action on the ground. This phase of the operation was defined by caution and calculation rather than urgency. Each vehicle was carrying a large volume of fentanyl, and any loss of control on an open highway could have triggered a public health emergency. Because of this risk, planners treated every movement as a potential point of escalation and designed the operation to limit exposure at every step. The first major decision involved where the trucks would be stopped. Federal teams selected abandoned airfields, decommissioned military bases, and isolated industrial areas with minimal civilian traffic. These sites offered wide access roads, predictable layouts, and space for heavy vehicles to maneuver without interference. Just as important, they allowed law enforcement to establish secure perimeters and control sightlines, reducing the chance of unexpected encounters with the public or private vehicles. With the locations chosen, cyber specialists began adjusting routes from inside the control network. These changes were introduced gradually to avoid triggering safety protocols or alerting external observers. The trucks continued to appear as routine freight traffic to monitoring systems, maintaining steady speeds and standard lane behavior. In reality, their destinations were being quietly redirected towards secure zones prepared for interception. As each truck approached its assigned site, field units moved into position in carefully timed stages. Blocking vehicles were placed to limit movement options, while perimeter teams ensured that surrounding roads remained clear. The emphasis was on containment rather than confrontation. Officers were instructed to avoid sudden actions that could cause unpredictable responses from automated systems operating at full speed. Disabling the vehicles required specialized tools and disciplined execution. Electromagnetic pulse equipment was used to interrupt electronic control systems without damaging mechanical components or compromising the trailers. This approach allowed each truck to come to a controlled stop, preserving the integrity of the cargo and preventing any release of hazardous material. Once immobilized, the vehicles were secured and prepared for transport to controlled facilities. Throughout the process, coordination between cyber units and field teams was continuous. Real-time monitoring allowed analysts to confirm that software adjustments aligned with physical containment measures. If a truck deviated from expected behavior, teams were ready to respond immediately. The absence of human drivers removed the need for arrests at the scene, but it also meant that every possible outcome had to be anticipated in advance, leaving little room for improvisation. By the end of this phase, all 19 trucks under federal control had been successfully neutralized. Approximately 38 tons of fentanyl were seized, secured, and removed from circulation. No civilians were injured and no officers were harmed during the operation. This result reflected the effectiveness of planning that prioritized safety over speed and intelligence over force. From a strategic standpoint, this phase demonstrated how autonomous threats can be managed without resorting to aggressive tactics. The success of the operation showed that even systems designed to resist interference can be guided into controlled environments when software access and physical coordination are aligned. Neutralizing the majority of the convoy reduced immediate risk and narrowed the problem space, allowing authorities to concentrate resources on the remaining vehicles still moving toward major urban areas. After 19 autonomous trucks had been brought under control in isolated locations, 4 vehicles continued moving toward major population centers, creating the most sensitive phase of the operation. These trucks were approaching Chicago, New York, Miami, and Seattle, cities where dense traffic, layered road systems, and constant civilian movement sharply limited enforcement options. At this point, the challenge was no longer only about stopping illegal cargo, but about preventing disruption to urban life and avoiding any incident that could place large numbers of people at risk. Unlike earlier interceptions, these 4 trucks could not be redirected through software access alone. Federal cyber teams confirmed that control over their operating systems remained incomplete, which ruled out remote rerouting to airfields or military sites. As a result, authorities had to operate within active city infrastructure where mistakes carry immediate social and political consequences. Any sudden stop, collision, or mechanical failure could have caused traffic paralysis or exposed first responders and bystanders to hazardous materials. To address this risk, planners adopted a coordinated mobile containment strategy. Instead of confronting the trucks directly, law enforcement units reshaped the driving environment around them. Heavy vehicles and portable barriers were positioned in advance, allowing officers to manage surrounding traffic without attracting attention. By controlling access points and narrowing available lanes, teams created controlled corridors that guided the trucks forward while quietly limiting their options. As these corridors tightened, the autonomous systems processed their surroundings using built-in safety parameters. Each possible route was evaluated against risk thresholds related to proximity, speed, and obstacle density. With no path meeting acceptable safety conditions, the systems responded as designed by reducing speed and initiating controlled stops. This outcome was achieved without physical force, relying instead on the logic governing automated decision-making. Once each truck stopped, tactical teams moved in to secure the area. Electronic systems were disabled, trailers were isolated, and hazardous material procedures were implemented immediately. The focus remained on efficiency and discretion. Traffic disruptions were kept brief, and public exposure was minimized. During this phase, approximately 12 additional tons of fentanyl were recovered, bringing the total seizure close to 50 tons across the entire operation. Local authorities played an essential supporting role throughout these actions. City police departments assisted with traffic management, while emergency services were placed on standby to respond to any unexpected developments. Clear coordination ensured that normal city functions resumed quickly after each interception. The ability to operate within busy metropolitan areas without triggering widespread disruption underscored the level of preparation behind the strategy. By the end of this phase, all 23 autonomous trucks were under federal control. No civilians were injured, and no officers were harmed during the urban operations. The containment of the final 4 vehicles demonstrated that even in complex city environments, automated threats can be neutralized through planning rather than force. It also highlighted the importance of cooperation between federal agencies and local governments when responding to technology-driven risks. This final containment closed the operational chapter of the case. With the vehicles secured and the cargo removed from circulation, authorities were able to shift attention away from immediate field actions. The success of this phase confirmed that controlling space and behavior can be more effective than confrontation, especially when facing systems designed to operate without human judgment. It also reinforced the idea that future enforcement efforts must account for how automation changes the balance between mobility, safety, and control in modern cities. As the autonomous convoy continued moving across the United States, federal authorities confronted a tactical reality that made traditional highway enforcement ineffective. The methods normally used to stop smuggling vehicles were quickly ruled out because of the unique risks involved. Shooting at a truck was not an option, since any penetration of the trailer could release fentanyl into open air. Even a small spill could contaminate road surfaces or nearby drainage systems, creating an immediate public health emergency rather than a controlled law enforcement outcome. Forcing a collision or attempting to ram a vehicle carried similar dangers. Each truck weighed tens of thousands of pounds and traveled at highway speed, meaning that any loss of control could trigger multi-vehicle crashes. Such incidents would place civilians at risk and shut down major transportation corridors used for commerce and emergency response. From a political standpoint, the fallout from a serious accident involving toxic cargo would extend far beyond the operation itself and invite intense scrutiny of enforcement decisions. The vehicles themselves further limited physical intervention. Each truck was equipped with advanced sensor systems, similar to those used in military or high-end commercial platforms. These sensors continuously monitored surrounding traffic, road conditions, and obstacles. When law enforcement vehicles moved closer, the systems responded automatically by adjusting speed or increasing distance. Because the trucks were guided by software rather than human judgment, tactics that rely on fear, hesitation, or negotiation had no effect. Real-time traffic data added another layer of complexity. The autonomous systems processed live information from traffic management sources, allowing them to adapt routes almost instantly. Roadblocks, checkpoints, or lane closures could be detected and avoided within seconds. What once served as reliable interception points became temporary disruptions that software could bypass with ease. Public highways, designed for efficiency and flexibility, effectively became tools that supported continued movement. Predictability also worked against enforcement. Human drivers often display stress, fatigue, or inconsistent behavior that alerts officers to potential criminal activity. Autonomous vehicles do not tire or panic. They follow traffic rules, maintain steady speeds, and avoid erratic maneuvers. This made them difficult to distinguish from legitimate freight traffic during routine patrols, especially in areas with heavy commercial flow. Taken together, these factors forced U.S. agencies to reassess their approach. Physical pursuit alone could not neutralize the threat without unacceptable risk to the public and to officers. Escalation on active roadways threatened environmental contamination, infrastructure disruption, and loss of life. The problem was not simply the presence of illegal cargo, but the intelligence guiding its movement across the highway network. This realization pushed enforcement strategy away from direct confrontation and towards system-level control. Instead of focusing on stopping vehicles by force, authorities began targeting the digital architecture that directed them. Communication pathways, software logic, and control protocols became the primary points of influence. Cyber operations offered a way to shape vehicle behavior while keeping systems stable and predictable. The shift marked a broader change in how modern threats are addressed. Control of physical space alone was no longer sufficient when automated systems could operate across jurisdictions without human involvement. Security now depended on understanding and influencing networks as much as territory. The failure of traditional interdiction methods in this case did not reflect a lack of capability. It highlighted how automation has transformed the operational environment, requiring new tools and new thinking to protect public safety under evolving technological conditions. The operation ended with results that immediately pushed the discussion beyond arrests and seizures and into the realm of long-term national security. Federal authorities confirmed that all 23 autonomous trucks had been brought under control and that nearly 50 tons of fentanyl were removed from circulation. The scale of the seizure alone placed the case among the largest synthetic drug interdictions in American history, yet its significance rested less on volume and more on what the operation revealed about evolving threats. Equally important was the absence of casualties. No civilians were harmed, and no officers were injured during the interdiction, despite the complexity of the operation and the density of the environments involved. This outcome underscored the importance of restraint and planning in modern enforcement. It also demonstrated that high-risk technologies can be neutralized without escalating into public disasters when intelligence and coordination are applied effectively. The arrests that followed confirmed that the convoy was not the product of improvisation. Key organizers and technical operators were taken into custody and charged under federal law, reinforcing the view that this was a structured system supported by specialized expertise. The dismantling of these leadership nodes disrupted not only a single shipment, but a broader operational model that relied on automation to bypass human vulnerabilities. In response to the case, U.S. lawmakers moved to strengthen regulatory and criminal frameworks governing autonomous systems. New legislation introduced mandatory remote shutdown capabilities for large, self-driving vehicles, ensuring that authorities retain a mechanism of last resort when control is lost. Expanded tracking requirements were also imposed to improve visibility of autonomous vehicles operating across state lines. At the same time, sentencing guidelines were updated to impose harsher penalties on crimes that exploit automated technology, reflecting concern over the potential for scale and speed to amplify harm. From a strategic standpoint, the implications extend well beyond narcotics enforcement. The case demonstrated that autonomous platforms can function as delivery systems that operate without direct human oversight, using civilian infrastructure in ways that challenge existing security assumptions. Roads, logistics networks, and regulatory systems were all tested under real conditions. The fact that the operation ended without casualties does not diminish the warning it provided. Looking forward, this incident signals a broader challenge for American security planning. As automation spreads across transportation and industry, the line between civilian innovation and weaponization becomes increasingly thin. Protecting national security in this environment will require coordination between law enforcement, legislators, and technology developers. Control of territory alone will no longer be sufficient. Control of systems and code will be just as critical in preventing future threats from emerging within the nation's own infrastructure. This case shows how fast technology is changing the security landscape inside the United States. Share your thoughts and subscribe to Military Power to stay informed as we break down the real stories shaping America's security today.